Let's talk about model complexity and overfitting. Overfitting kind of sounds like a paradox, right? When you first think about it, you kind of think, well, I want as complicated of a model as possible, such that my machine is able to be as accurate as possible. Overfitting is against that idea. It says that if you make the model too complex, you will actually make your model be able to make worse predictions. That sounds a little bit odd, but I think it's best explained with a picture. So let's take one of these mathematical functions, f of x, where we want to classify apples as a 0 and bananas as a 1. If our data was perfect, then a sigmoid function will always do perfectly well. But now let's say that there's kind of a muddied area here in the middle, where there's some bananas mixed with some apples. You might think that you want to have your model fit the data perfectly, in which case what it will have to do is it'll have to say this is a banana right here, and then an apple, then a banana, then an apple, banana, apple, and then mostly bananas over here. This model technically will have fit our data better, but this part right here will be an issue. The reason is because we can kind of see how this model should be working, right? On the left side, we should be giving zeros for apples, and on the right side, we should be getting 1 for bananas, and as we go from left to right, we should be increasing our probability of being a banana. However, this overfit model ends up saying apple or banana in very wild ways in the middle. And what this means is that it's fitting this weird random noise which showed up in our data, which might not actually be there in reality, right? When we get a new data point that's right next to this apple, it probably is an apple, but over in this side, this apple is probably an anomaly, right? If you get a value of green, which falls over here, you would probably expect it to be something like a banana. And this one apple is just kind of an odd picture. But instead, the overfit model will say anything that's in this area is an apple, which is what we would not have wanted to see. So overfitting, the problem with it is that it's fitting our data that we train it on too well, and so it doesn't generalize to new data sets. Now, what are some ways that you can get rid of overfitting in your model? The main ways are known as cross-validation. So cross-validation techniques, what they do is they leave out data points. So you start by saying, let's take this data point here, this data point here, this data point, or these two here, and this data point over here. What you can do is you can leave those data points out, you can train a model, and then what you can do is you can see how well your model does on the data points that it never saw before. So what would happen is that this model that is overfit would do very poorly on the data that it had not seen before, because it would try to get these wobbly lines correct, but it could not get that correct in every case if it didn't know all of the problems here. But a line which is smooth like this would on average get the points that it never saw before mostly correct, because it's moving in the right general direction. And so by decreasing some model complexity and by reducing the fit to the actual data that we see, we're able to make our model better generalized to new data, which means that when new orders come in on Amazon, or when new users come and ask for a movie recommendation, we're able to get them the correct recommendation instead of only being able to do well on the data we've already seen.